Right, for question 18, they're saying as P equals to sec theta minus tan theta and Q equals to sec theta plus tan theta, prove that P equals to 1 over Q. Right, so we have to somehow manipulate P and Q into this form, and the way I would do it is I would avoid the trial and error of doing stuff like P plus Q, P over Q, all different types of stuff. I'd bring around P equals to 1 over Q, and I'd write down what this means. Sec theta plus tan theta equals to 1 over Q, which is sec theta plus tan theta. Apologies, as this is P, it should be minus tan theta. So let me put minus. Right, so we'll bring over this sec theta plus tan theta to the left hand side. So now we're going to have sec theta minus tan theta times by sec theta plus tan theta equals to 1. Now when we look at this, we have to somehow prove that this works, that somehow sec theta minus tan theta times by this equals to 1. We need to somehow prove this. We can look into our identities and we can see this identity. Sec squared theta equals to 1 plus tan squared theta. The reason I bring about this identity is because it's very similar to what's happening here. There's a sec theta, there's a tan theta, and there's a 1. So this should be some sort of connection with this. What we can next identify is that these two is like a difference of two squares, as we have our base sec theta, and then there's a minus and the plus, and then the tan theta. So it must have originated as this, sec squared theta minus tan squared theta. As you know, when you do difference of two squares to this, you'd factorize into this. So we know that this becomes that. And as we have this now, this equals to that. We look at this equation and we say sec squared theta minus tan squared theta equals to 1. And therefore it proves that this should equal to 1, as it says over here. Therefore we can say that P equals to 1 over Q.